This conference will now be recorded.
Okay, screen is visible, students. Confirm once. Yeah. Okay. Let us start today's session. Today, we are going to discuss about recursion. What is called recursion? Recursion in computer science is a mechanism. It is a methodology where the solution to a problem depends on smaller instance of the same type of problem. I repeat, recursion in computer science is a methodology where the solution to a problem depends on smaller instance of the same type of problem. What is the meaning of this word smaller instance? Because in the entire definition, that is where if you have any issue, this is the place. What is this smaller instance? Suppose if I ask you to find factorial of 3, then immediately you will say that 6 is the answer. If I ask you what is factorial of 5, then you will not be able to give that factorial 5 also will tell, sir, 120. But if I ask you what is factorial of 99, you will not be able to give the answer. So what you will do? If I ask you, tell me what is factorial of 99, what you will do? This thing immediately you are giving the answer. But for factorial 99, you are not able to give the answer quickly. Why? So currently this is the problem. What is the problem? Finding factorial of 99 is the problem. This is the problem to you. Then what you decided is that, okay, I will divide the problem into smaller instance. But how you will divide this problem into smaller instance? For that purpose, actually, definition of factorial is well defined. Definition of factorial is well defined. What is that rule? This is the formula. N factorial is equal to n minus 1 factorial into n when if the value of n is greater than 0 and is equal to 1 if n is equal to 0. And one important point is negative number factorial is undefined. So now what you will do? You will check that is this 99 is equal to 0 or it is greater than 0? Sir, it is greater than 0. Then immediately what you will do? You have the formula, na? You will put there. You will immediately say 99 factorial is equal to n minus 1 means 98 factorial into n means 99. So that means what? Now you are expecting that if anyone provides you factorial of 98, with that result you will multiply 99 and you will give the answer. But the question is, who will provide you this? Who will provide you this? No one is going to provide you this value. That means what? Now this is your problem, because multiplication with 99 is not the problem. Multiplication with 99 is not the problem. Problem is 98 factorial, sir. So you see, you started with 99, this problem, and currently this is your problem. So it becomes smaller or not? Your problem size becomes smaller or not? And same instance means it is factorial, it is also factorial. But what is that 98 factorial, sir? Again you are approaching here. Is it 0? No. Greater than 0? Yes. What I will do? You will say it is 97 factorial into 98. So that means what? If anyone provides you 97 factorial, multiplication is not a big issue. You will get that. That result you will multiply with 99 and you will find that final solution of 99 factorial, which is your original problem. But the question is again, who will provide me, sir? No one is providing you. Then same, this means 96 factorial into 97. In this way, continuously it's happening. It's happening. It's happening. One day you will find that it's a 2 factorial. And again, same application is 2 greater than 0. Yes, sir. That means 2 factorial is equal to 1 factorial into 2. Then 1 factorial is equal to, sir, is 1 greater than 0? Yes, 1 minus 1 means 0 factorial into 1. Then 0 factorial is equal to, again you come here, is n greater than 0? No, is equal to 0? Yes. Now for this one, you know the result. You don't have to depend on anyone. You don't require to depend on anyone. Factorial 0, you know the answer. What is that? 1. Then immediately you will say, sir, I will put this value here. I got 1, I will put this value here. Then 1 into 1 become 1. 1 factorial I will get. Then I will put it here, that value. That is also 1. 1 into 2, 2. Then that 2 factorial I will put it here. 3 factorial I will put it here. In this way, sir, one day I will put 96 factorial here. I will get 97. One day I will get 97 factorial. I will put it there. I will get 98 factorial. Then I will put it there. I will get 99 factorial. So what we have done here to get the solution, isn't it? Solution to the problem. What is your problem? Finding factorial of 99. To get the solution to this problem, it depends on smaller instance of the same type of problem. It is factorial means smaller instance is also factorial, 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 but smaller, 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 smaller. In this way, one day we'll get the solution. Na? This is nothing but known as recursion. That's why we said that recursion is a methodology where solution to a problem depends on smaller instance of the same type of problem. Now another thing what we can conclude from here is that you see what you are doing, factorial of 99 you are expecting. For that purpose what you need, factorial of 98. For this what you need, sir, factorial of 97. You see one thing, this factorial word is common. So means what? Factorial 99 is calling factorial of 98. Factorial 98 calling factorial of 97. He will call 96. He will call 95. Like sir, in this way it will be going on. How long? In your entire lifetime it will be going on and on and on. No, 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 no. Someday it will stop. You see, 98 is requirement of 98 factorial. 98 factorial requirement is 97 factorial. 97 requirement is 96 factorial. In this way, 2's requirement is 1 factorial. 1 requirement is 2 0's factorial. 0's requirement, are you going to say negative? No, negative number factorial is undefined. So one day we will stop now. Breaking the problem smaller, 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 smaller. One day we will stop. That means one day this calling 99 calling 98, 98 calling 97, 97 calling 96. One day this calling will be stopped. That stopping condition in recursion terminology is called as base condition, or some people call it as stopping condition. Base condition or stopping condition. So base condition is what? Suppose someone is asking, you have to tell base condition is such a condition for which function will not call himself. Before reaching the base condition, 99 calling 98, 98 calling 97, 96, 91, 93, 94, 95, 94, 93, 92, 90, 89. But sir, I reach such a condition for which no function calling, because 0 factorial is not calling anyone. He's directly give me the answer, but no other fellow directly giving the answer. Only 0 factorial directly give me the answer without calling anyone. That's why he is termed as base condition or stopping condition. He is termed as base condition or stopping condition. You read this line. Recursion is a process in which function calls itself. Why itself? Are 99 factorial calls 98 factorial. So factorial to factorial, isn't it? It calling itself. Isn't it calling itself? Yes. Only one type. No, no, sir. Repeatedly. This, repeatedly. How long? Until some specified condition is satisfied. And what is that specified condition? For factorial, problem statement to problem statement, that condition will differ. But for factorial, that specified condition is factorial of 0 is 1. That is the specified condition for factorial. And that's why it stopped here. When the specified condition is satisfied. No more calling. Please, no more calling. Stop, stop, stop. You reach to the base condition. You have reached to the base condition. Now, programmatic point of view, how we will implement. What is the next line? Each time the function calls itself, check it out. 99 call 98, 97, 96. Every time you are calling with smaller instance now, somehow you are approaching to the solution. Somehow you are approaching to the solution. Suppose you say, sir, after this I will not do anything. I will wait, someone will come and someone will give me the value of factorial 96. I will put it here, I will multiply, I will get 97. Then remaining steps I will do and I will tell you this result. Thinking that you are waiting 1 day, 2 day, 1 month, 1 year, 10 year, your entire lifetime gone, no one is coming and giving you this result. Because it's your responsibility. You have to find. So that's why once you stop means you will not get the solution. But you said, no, I will do that, I will do that, I will do that. Then definitely you are approaching to solution now, because one day it will be stop calling. On stop calling, you will get this value, this value, this value, this value, this value, you will get the solution. So that's why each time the function call itself, here whose function I'm talking about, factorial function. Each time the function call itself, it must be closer in some sense to the solution, means I'm approaching to the solution. If I stop calling, I will not get the solution. And here the biggest question that arises, sir, how long I will make the calling? That's why they said that there must be some stopping condition, must be, for which the function does not call, and that stopping condition is known as base condition or stopping condition. By mistake, if the base condition was not there, no stopping condition is there, your recursion will become infinite recursion. Your recursion will become infinite recursion. Like loop can become infinite loop. Remember menu driven programming, while one infinite loop. This is not infinite loop. This is infinite recursion. Someone is asking, tell me what is the process of making a finite recursion to a infinite recursion? You will say simply remove the base condition, simply remove the stopping condition. Your finite recursion will suddenly become an infinite recursion because there will be no stopping condition. It will be calling forever. Then how it will stop? Next, sir, how we will approach, how we will achieve this recursion programmatically. So I will take a simple program first. I will show you internal structure of that. This is your, when you learn C programming language, this is your favorite program, finding factorial of a number using recursion. But how this thing is internally implemented, that picture I will give today. Writing that program is very easy, sir. Writing that program is very easy. Factorial of a number, of a given number, using recursion. I will give the internal things, how it works, because writing program is very easy. What you will do, sir, I want to give a message, prompt. What is that? Enter a number. Enter a number. Who will enter? User. To take the input from the user, which function we need? Scanf. Integer value format specification is %d. Ampersand is compulsory to read the input value. This part is for reading input. Next, sir, you are using n here, na? Declare n. Variable declaration done. What I will do? I will call the function fact, and there I will pass n as the argument. I will pass n as the argument. Then immediately, what is our next job? Sir, define that function. Where? Above main. We have learned, na? Fact. Int n. Sir, can I take n here? Sir, any variable name you can take. It's a local only. This n belongs to main and this n belongs to fact. Any name you can take, not issue. Now what I'm doing here, I'm writing if. By seeing that definition, guys, just by seeing that definition, I will develop the program. What is that definition, sir? One condition I found that, sir, n is equal to 0. So if my n is equal to 0, I will write here, if n is equal to 0, return 1. Where this 1 will come, guys? Sir, this 1 will come here. But you need to print the value, na? Otherwise, by capturing that, you are not capturing. You need to print the value. What you will do? You will say, sir, I will do one thing. I will write the message here. Printf the factorial of %d is %d. First %d means factorial of n. Okay. Second percentile d means this result, fact 10. First bracket close, story ends. But here, sir, in program is not completed yet. Return 1. 1 is the integer value. So what should be the return type? Int. But this program will only calculate the factorial of 0, nothing else. Check it out. Compile and execute, enter a number. 0. Factorial of 0 is 1. Okay, no problem. I want to enter another value. I want to enter 2. Do you think it will work? I want to enter 3. Do you think it will work? No, sir. Because for only n the logic is written. 0 for the 0 logic is written. For the 0 logic is written. For 3 the logic is not written. That's why giving incorrect answer. Factorial of 3 is 3. Is factorial of 3 is 3? No, 6. Why it is giving 3? Incorrect result, sir. Incorrect result. It's not working. Then from where 3 is coming, sir? You enter here 3. Your number is 3. Factorial of percentile d, that means 3 is percentile d, fact 3. Control came here, not finding anything. Here simply putting some value, arbitrarily coming that 3. But I'm not expecting that, sir. I'm expecting here the expected value, desired value, 6 I'm expecting. Then you have to write the code. How? If n value is not equal to 0, where is your code? Not there, na? Else. What you will do? I need value here, na? Here I need the value. So if you need the value here, definitely you have to go for return. Definitely you have to go for return. But what you will return? Again, I will take the help of formula. This is my formula. What I will say? Return, observe here, n minus 1 factorial. What I will say? Fact of n minus 1 into, what is that? N. Students. Now you execute factorial of 3. 6. You give 5. 120. But after a large value, maybe 7 or 8, you will not get the expected result, because that number, whatever has come as a result, it will be more than integer range. So that's why from the beginning, it will be better if you take the variable as long. For long, percentile LD. Here also everything change it to long. Here also it will be long. Now you can enter any value. 7, 8, 9. With integer, the problem is up to 7 or 8 you can calculate. After that you will not be able to get the desired value. That's why I change it from integer to long. Long is having a more range na. Okay, up to 7 no problem. After 8 it will be the problem if you take integer. See, factorial 8, this is the value. But if you are keeping it integer, you will not get. Check it out. If you are simply keeping here integer, you will not get. Achha, 8 working. Maybe let's see 9. Achha, this compiler size of the integer is 4 byte, I think. 1 minute, guys. Let me check it out once. Printf size of, we have used learn na size of operator. This compiler size of integer is 4 byte. If it is 4 byte, no problem. It's a big range. 4 byte is a big range. For 4 byte, it will not create a issue. But if it is a 2 byte compiler, it will surely create issue. For a Turbo C DOS version, there definitely you have to go for taking long. Here size of integer 4 byte. Yeah, so no issue. With integer also it will work. But if you are working any compiler file 2 byte, where size of the integer is 2 byte, generally, let me show you this type of compiler. See here, this one, Turbo C++ DOS version. Their size of the integer is 2 byte. For those compiler, you cannot go for taking int. Why? Because their integer range is like this: -32768 32767. This is the range of integer for 2 byte integer. That's why when you calculate that factorial 8, what is that value came? 40,320. Isn't it? It is beyond the range. That's why never get the proper output. In those compiler, you have to go for long. But here no problem, as because 4 byte integer means it's a big range, sir. -21, 47, 48, 36, 48 to 21, 47, 48, 36, 47. This much big is the length of integer in case of the 4 byte integer. That's the reason even you take integer, not a issue. But if anywhere creates problem, not getting, change from integer to long. Now how this program will internally work, sir? Outputs coming, everything is okay. But how it will work internally, how the recursive function internally work, that clarity I will give it now. Observe here. This is my coding, sir. This is the main function. This is the fact function. Now for both of them, I'm entering some numbering value. Line number 1, 2, 3, 4, 5. One, 2, 3, 4, 5. Same way, here also I'm having line number. Okay. You know that who calls operating system? Who calls main method? Operating system calls the main method. Operating system calls the main method. For execution of function, operating system provides a data structure. What is that data structure? Stack. Stack is having how many end? One end. What operations are possible for stack? They ask which data structure is provided for, recursion. You have to give the answer as stack. In a reverse angle, give me one application of stack. In recursion, stack is used. What operations are there? Push, pop, pick. Currently, we are not interested about pick. We are interested about these two, push and pop. Now, this is my operating system, sir. This is my operating system. He take the responsibility of calling the main function, because function need to be called, otherwise execution will not start. This is my main. Operating system calls him. Operating system calls him. Main, can you please come? Main says, yes sir. Start execution. Programmer has written a program, please do start execution. And now main have to follow the instruction of operating system, because to you main is the boss. You thought that sir in my program main is the boss, but to main operating system is the boss. Boss calling means he have to follow the order. Main started execution. Line number 1 sir, variable declaration as int n. Main says okay, for this variable let us allocate some memory. And have some address. Line number 1 done. You are approaching to 2. Printf message means something came into the console. Scanf means you have to take a user input, and you have taken a user input, say 3. You have taken the user input as 3. The user input value you have taken it as 3. Okay sir. After taking the user input as 3, again you start making a movement. Line number 4, again a printf statement sir. You will wait, because something will be printed in the console. For that purpose you are waiting. But when it goes for printing into the console, into the console, a big issue came sir. What is the big issue? Sir, the factorial of percentile d is this. This is what is going to be printed now in the console. And there, this percentile d will get the value from where? From this n. Do you have n value? Yes. What is that? 3. Immediately, this fellow replaces 3 here. Replaces 3 here. But the problem is, okay, factorial of 3 is no problem. Up to this, no problem. You move, you are moving. This part done. The factorial of percentile d. This fellow expect the value to be from this person. He is expecting the value from this person, because remaining other things already are done. Everyone have completed their activity. Just percentile d is expecting value from here. But what about fact 10 sir? Fact 3. What is fact 3? I mathematically know, but programmatically I don't know. That means from here, from this location, currently you made a function call. From here you made a function call. So that means from here, now the control will go. Where it will go? Sir, to the function. Where is the function, guys? This is the function. This is my function. This is where the control comes. This is where the control comes. With what value it is coming? N value, sir. What is your N value? 3. So then with what value it is coming? 3. With 3 it is coming. N value is coming 3. Here it is 3. So from where you call the fact function? Main. So who calls fact function? Main calls the fact function. Main call the fact function. With what value? 3. With the value as 3. Super. Main made the function calling as 3. So who will start execution now? Fact 3. Now we know now one fellow is there, guys, as our instruction pointer. He will remember that when the control will come back to main, this printf is not completed. Printf is partially completed. Factorial of 3 is then stuck. So this is the line from where execution will start. So what is that line, guys? 4. Instruction pointer will remember when the control will come back, I will start execution from 4. Because 4 is the line where I start. Fact 3 started execution. Fact 3 started execution. Fact 3 started execution. Line number 1 done. Is n 0? No. Return 1 will execute? No. Coming to else what? Return. But to return, if we have to return, it came here. Return will execute, definitely execute. But return will execute in only that case if you have this value and this value. But currently you have this value 3, but you don't have this value because it's a function call. It's a function call. So that means what, sir? This multiplication into 3. But with what? With what? That part becomes pending now. So fact 3 was executing, sir. Fact 3 was executing, progressing superbly. N value captured as 3. N value captured as 3. But location? No, his own memory location. Some value 200. Captured as 3. But somewhere while executing line number 4, suddenly got a multiplication value. Something with multiplication. But what is that something he doesn't know? And for that purpose, he made a function call. What is that function call? Put it here. Fact 2. Oh, function call. No, sir. Yes. Function call means you know. Sir, one instance will be created in the stack. with what value? 2. Who calls fact 3? Is it main calling? No, sir. Then who is calling that fact 3? Sir, who is calling that fact 2? Sir, fact 3 calls fact 2. Anything is pending in the fact 3 function? Yes, sir, multiplication is pending. And as a result, return becomes pending, because without multiplication, how can he return? So the instruction pointer for the fact 3 function will say that when control will come back to me, I will start execution from line number 4. Currently, I am unable to do that. And for that purpose, he made a function call to himself. That means, sir, again the function will be executed. But this time with what value? This time with the value 2. 1 minute, guys. I need some space to adjust. Yes, guys. So second calling has been made with 2, sir. Super. Execution will again start. Whose execution? Sir, fact 2 function execution. Beautifully capturing n value. This time what? Is it 3 or something else? No, sir, not 3. This time 2. Location, his own memory location, some value, sir. Some value. Currently, I'm not dealing with pointers, so that's why I'm not that much interested about what address, etc., etc. But some value, sir. Some address value. Received value here is 2. Fact 2 started execution. Doing, execute, no. Else will execute. And in the else, again, same problem. Fact 2 is again have the same problem. Not having any issue with the n value, because n value is 2, not a issue. But the problem is this fellow, because it's a function call. And without function call, I will not know the value, sir. That means what, sir? From here, again a function calling is made. From here, again a function calling is made. This time with what value? With 1 value, sir. This time with 1 value. Super. So that means fact 2 is having the same problem. Don't know the value, want to multiply with 2. And in that purpose, made a function call. What is that function call? Fact 1. Who called this? Fact 2 called this. So fact 2 is the caller. Immediately instruction pointer for fact 2 will say, I will remember this value when the control will come back to me. And what is that? 4. Line number 4. fact 1 started execution. N value 0, no. Return will execute, no. Else what? Yeah, else what come. It come to the else what. Return, oh sir, again same problem. Into 1, no problem because n value is 1. But he also made a function call. What is the function call? Don't know this value. Made a function call. What is that, sir? Fact 0. Fact 0. So that means from here, one more time the function getting called. This time with what value? 0 value. 1 minute please. This time with what value? 0 value. So that means who called this fact 0? Sir, fact 1 calls the fact 0. Fact 1 calls this fact 0. Why? Because he was unable to calculate and stuck at the same point. What point? He received the value as 1. That's not a big issue. But while multiplication he tried, na sir, he stopped. And hence called that fact 0. So he also stuck at that point, na, multiplication point. Yes. So the instruction pointer for him will remember what value? Same line number 4, sir. Same line number 4. So who will now start execution? Fact 0 will start execution, sir. Fact 0 will start execution. Let's start execution of fact 0. Let's start execution of fact 0. N value is 0. If n is 0, n value is 0. Return 1. Where to return? Fact 0 started execution, receiving the n value as 0. Super. Receiving the n value as 0. N. Some address. Say 500. After execution, means at the time of execution, he found that array n value is 0. For the first time, your program inside the fact function will enjoy the if block, because earlier on all cases when that n value was tested, every time it found that n value is not 0. For the first time he got that n value is 0. Check it out and return 1. But where to return, sir? Started from May, now came back to fact 0. Where to return? Array to your caller. To your caller. Who is your caller? Fact 0. My caller is fact 1. So return that value to your caller. Okay. Then what value will return? 1. The value that will be returned is 1. Now fact 1 was stuck, guys, because he was not having that value. Now suddenly by getting this value, he felt very happy, because earlier he was not able to do that multiplication because he was not having that value. Currently he received the value from fact 0, and now he is telling, array, I will do the multiplication. Once he will do the multiplication, in the meantime fact 0 story completely end, na? Removed from the stack. Simply removed from the stack. That means pop operation, sir. because fact 0 story end, control came back to fact 1. No question of keeping it that in the stack. Earlier made push operation, sir. Now started making the pop operation. Started making the pop operation. Story ends for fact 0. Control came back to fact 1. He is doing the multiplication, and once multiplication is done, he will say return 1. Because 1 into 1, 1 na? Then where he will return? To his caller. Who is his caller? Fact 2, sir. Fact 2 was stuck. Long back fact 2 was stuck. Not able to calculate because he was not having that value. Now suddenly he got the value and felt very happy. What value he got? Sir, he got the value as 1. Once he got this value as 1, he was hungry like anything because unable to do the processing na guys. It's like you people, when you become hungry, program log functions like that. If there stops, like they're hungry. They got stuck. Now got the value. Once got the value, started celebrating. Are I will do the multiplication now. I will do the multiplication now. Like he is celebrating. And once multiplication is done, return is there. Return is telling you do multiplication, I will return the value. You just do the multiplication, I will return the value. Because you stuck, I stuck. That's the feeling of return. Why return stuck? Multiplication was not possible. Now once multiplication is done, return is telling I will return the value. Are where will return the value? To the caller. In the meantime, what happens, sir? Fact 1 instance is done. And when the value will be returned, sir, when the value will be returned, where it will be returned? To fact 3. This instance will also be, removed. Then what value will be returned? 2 into 1, 2. Now fact 3 started celebrating. He is telling, Array, I am the fellow who is waiting for the longest period of time. I am the fellow who is waiting for the longest period of the time. He started celebrating. Why, sir? He received a value here. What value? 2. And of course, here not n, because to him, the actually n means what, guys? To him, n means 3. N is 3 now here. Not n, sir, it's 3. As soon as this value came, now multiplication will happen. And as multiplication will happen, return fellow is there. He will tell, I will return the value. You do, I will return the value. Then once multiplication done, return is happening. And this instance is removed. This instance is removed. Where the value will be returned? To main. Main is telling, Array, you people are telling that waiting for a longest period, longest period, longest period. You know, myself is the fellow who is waiting for the longest period, and you people are, you people are responsible for me only. I am the fellow who made you people hungry, because I am the fellow who called you. Entire problem started with me because I was trying to execute this line and I stuck it there. So I am the person who is responsible for, all this thing. So what the value is coming to main? Main 3 into 2, 6. 3 into 2, 6. Instruction pointer here is telling 4, line 4 got stuck. Go to line 4. Here it's stuck now. Fact 3 now got a value because it came now. Value came here. You called fact 3. Now fact 3 is giving you something. Main called fact 3 now. Fact 3 is giving it something. 6. Then immediately will say, Array, in this place I got a value 6. I got a value 6. Then immediately percentile D will say, if you say here, I got a value 6. Percentile D will say, thank you very much. Thanks very much. I was waiting for that only. You give me 6. I will do the printing of that. Remaining things, everyone has done their job. Everyone has done their job. Output came. We felt very happy, sir. Learned two things: how recursion internally happens, how the recursion uses stack, application of stack with the help of push and pop function. Main printed the value, return 0. Super. Main will say, thanks very much operating system. It's you for that. Programmer came to know what is factorial 3 along with, factorial 3, you might say, sir, what is there in factorial 3? Without program I can do now. Now I will ask you factorial 99. Then so that's why now main is giving a big thanks to operating system. It's you only, you take the initiative. Programmer able to know the value of fact 3. Operating system will say, okay, very good. Now operating system is feeling that everything is finished. What is the point of keeping that stack anymore in existence? Unnecessarily memory wasted. Let me delete this stack. This total story, operating system provided stack. Where the movie took place, guys? Sir, the movie took place in operating system provided stack. You got the result. Factorial 3 is working. I understood recursion, sir. Everyone is feeling happy. Session ended. Tell me, student, understanding entire story behind recursion? Anywhere do you have any doubt? Or sir, I understood clearly. I have no doubt about recursion. Tell me, guys. Okay, Mohantika is telling, sir, no doubt. What about others? Yeah, fine. So now it's your duty to practice. Tomorrow we will have a session, guys. Same time, same link. Tomorrow I will take a session. Okay. Tomorrow I will show a beautiful problem that is called Tower of Hanoi problem. How to achieve that using this recursion. Okay. File, sir, save as. Okay, students. So I will share that note in your classroom, guys. But not immediately. I have another session to take. After that session, I will share this note. Both the note, that theory note, right? There also the example was clarified. But as I have done it in front of you, so that's why I will give you both the example. Whatever you like, from there you prepare your note and make it ready. Here also it is done. Same thing only, right? But whichever you like, that you can take that. I will share both the documents. Thank you, please.